Coming all math hours. This is our next Olympiad challenge. For how many rational number values of P, the area of the triangle made by the intercepts and the vertex of this quadratic equation is an integer. So you can see the quadratic equation made in the variable x. So when they mean intercepts, they mean the x-intercept. So since the leading coefficient is negative, that means it's a open downward uh, parabolic. So and like since they're talking about x-intercept, so the graphically it should be something like this. So then just think about it. These 2 points are the x-intercept. Let me name it as A and B. The vertex point here will be C. We're talking about area of this triangle only. So if they talk about area of this triangle, so you understand A to B will become the base of the triangle, and from C will give you the height. Okay, that means the y coordinate of this point will become the height. Okay, so very easily we know for a quadratic which is of the form ax square plus bx plus c, to get the vertex, we just have to substitute x equal to minus b by 2a. Yeah. So in this place, in the place of b, ax square plus bx plus c. In the place of b, we have 4p. So minus 4p by 2 times a. In the place of a, I have minus 1. That gives me 2p. If I substitute back x equal to 2p in this, substitute x equal to 2p in that, I'll get my y coordinate of my vertex. So my point C is my vertex. So see what's happening. So y equal to minus of 2p the whole square, 4p times 2p minus p plus 1. So this gives me 8p square minus 4p square. So 4p square minus p plus 1 will be actually my height of my triangle. This is going to become your height of the triangle. Now talking about A to B being your base. So this is actually a root of your quadratic alpha, this being root of your quadratic beta. So the difference between alpha to beta will give you the base, isn't it? So base is basically going to be mod of alpha minus beta. So I can call this as my formula of DOs, that difference of zeros. Difference of zeros of my quadratic will be nothing but my value for base. So to just think about quadratic roots formula, people, the formula is minus b plus or minus root of b square minus 4ac by 2a. That's your formula. So it has two roots. One is minus b plus root of b square minus 4ac by 2a. The other one is minus b minus root of b square minus 4ac by 2a. If you intend to do subtraction over them, you subtract both, what you will get by 2a will be there, and you will be getting minus b minus of minus b, so they'll get cancelled off. So this will give you 2 times root of b square minus 4ac by 2a. So 2 getting answer. This will happen to be a base. Okay. So a value being minus 1 for me, and root of b square minus 4ac will give me 16p square minus 4 into a value is minus 1 and c value is minus p plus 1. So this gives me minus 4 into minus 1 plus 4. 4 into minus p minus 4p. 4 into plus 1 plus 4. 16p square minus 4p plus 1 plus 4 by minus 1. This happens to be my base. So finally putting all this information that I have achieved in the area of my triangle. Area of my triangle comes to be half into base into height, half into root of. So I can take 4 common from this as well. So I'll be using a mod sign over this, right? This cannot go negative, correct? Because base has to be, the area of triangle has to be positive. So mod square root will give you only positive results. And minus 1 will have to be turned out to be plus 1. So I can take 4 common from this root. It will come out as 2. So inside the root, you will be finding 4p square minus p plus 1. So this 2 gets cancelled off. Half into base into height. So what did we get for the height? Height, we said the vertex is 2p, isn't it? And we substitute x equal to p, and we got height of triangle to be again 4p square minus p plus 1. So very good. So for how many rational number values of p, this will become an integer is my question. So you can notice both the values, this value 4p square minus p plus 1, this is also again root of 4p square minus p plus 1. Okay, so we understand if you want an integer answer, integer area, if you want an integer answer for area, the value inside this should be a square number, an integer square, correct? Integer area, for integer area, I understand 4p square minus p plus 1 should be equal to x square, where x is an integer. Okay, baby? That's our understanding here. So we got into another quadratic now. So 4p square minus p plus 1 minus x square equal to 0. Okay. So now I can write the roots formula. I know I'm interested in getting a integer root. Roots formula. So p being my variable here, minus b plus or minus root of b square minus 4ac. B square minus 4ac. 4 into 1 minus x square. 4ac by 2a. 2 into 4 is 8. Gives me 1 plus or minus root of. So here I have minus 4 into 4, minus 16. So plus 16 x square comes in. Okay. Minus 16 plus 1 minus 15 comes in, divided by 8. So this is my value of p here. So we can clearly understand the next step. The 16x square minus 15 should be a perfect square again. So we will keep 16x square minus. So students will generally come till here and they get stuck because they think, okay, it goes step inside a step. But that's where the sum actually becomes victorious for us. It should be a perfect square again. So keep it as y square, where y is an integer. So 16x square minus y square equal to 15. So this is where it takes a square minus b square type, 4x plus y into 4x minus y equal to 15. So we understand since x and y are integers, these two also be integers. 4x plus y will be an integer, 4x minus y will also be an integer. So product of two integers should give us 15. That's how it works. So like say I'll go with the case of 15 into 1. Like say 5 into 3. Okay. So both x and y, we took it to be like positive cases here. So that's how it's going on. So 4x plus y equal to 15 and 4x minus y equal to 1. If I take this, I'll be getting 8x equal to 16. That means x equal to 2. 4 to the 8 and then y will be 7. Okay. Similarly, if I take the other case, I'll be getting 4x equal to 8 will come. So x equal to, 8x equal to 8 will come. So x will be 1 there. Okay. 4 into 1, 4 plus 1. So y should be 1. Okay. This is how it spans out. We got the x and y values. Now what we need to do is we need to check because the question is about what is the value of p, right? So just substitute back. Now I'm going to substitute this case first. X equal to 2. So that let me getting my p value. If I substitute x equal to 2, what do I get? 2 square 4. 4 into 16, 64. 64 minus 15 is 49. Square root of 49 is 7. So 1 plus or minus 7 by 8. So my p values will be 1 plus 7, 8, 8 by 8, which is 1. 1 minus 7, minus 6 by 8, which is minus 3 by 4. Okay. That we got by substituting x equal to 2. Substituting x equal to 1, I'll get 16 minus 15, 1. 1 plus or minus 1 by 8. 1 plus 1, 2 by 8 will become 1 by 4. 1 minus 1, 0 by 8 will become 0. So we got 4 rational values. Now for people asking, sir, why not going for minus 15, minus 1, 1 into 15 and all? So we can take the cases and come to the final conclusion. Is there any other possibility values of b? So I'm cutting it short and leaving it as a work for you. Only these values will be our the possible rational values of p. Thank you all. Hope you loved this question.